Hey guys, welcome to this video. Today we're going to learn about merge sort and do an implementation of it in Python. So merge sort was invented by John von Neumann in roughly 1948 possibly. It was part of a divide and conquer algorithm that he came up with, and he came up with this in 1945. And John von Neumann was one of the smartest people in the 20th century, so the 1900s. He's one of the top experts in like mathematics, science, and lots of different fields. He's probably in the top 5 smartest people in the 20th century, if not like the top 3, if not the top 1. He's very accomplished individual, and merge sort was just one of the many things he accomplished. There's so many things he has done, lots and lots of things here. But anyway, so merge sort is one thing he's done, and how we'll go over exactly how it works, so you guys can get a better understanding of it before we implement it in Python. So merge sort is a recursive divide and conquer algorithm. What it does is it takes an array, list of something that you need to sort. It splits it up into 2, and then it keeps on splitting them up until there's like individual pieces left. And then at the very bottom of the pattern, it just merges the 2 and then merges the 2 until it gets back to the whole entire piece again. So there is sort of a graphical representation of it on the side here. Let's see if I can get it moving while zooming in. Okay, so there. So you can see there, it well, we kind of missed out the initial parts, but it basically you start off with like an entire array or something that you need to sort. And let me just click on it. See if I can zoom in some more. So you have like this entire array to sort. It splits it up in 2, splits up in 2 again, and then splits it up with some more and splits up some more. And at the very end, once it's down to the individual pieces, it starts putting them back together. And how it does that, you compare the values manually. You compare which one is higher, which one is lower, put the lower number first, and then merge them back together, and then do the same thing over and over again until you get back to the very top of the entire thing. So until you get the whole piece again fully sorted. So I disagree with that graphical representation because it is a recursive algorithm. So it starts off usually on the left side first. So there's this image here of how it's done. How I would describe it being done is that it starts off here, right? It starts off in this step. It splits it in 2, and then it goes down. It splits in 2, so right here. Now it goes down to this leftmost side first. Okay, it goes down to the very left first because it's a recursive algorithm. It goes to the leftmost first, and then it does the left side again. Okay, and then after that, I guess it goes to here, and it goes to here, and then it kind of merges it back upwards like that. It merges it back upwards, and then this goes down here, and then this goes down here, and this goes down here, merges it back upwards, merges this back upwards, merges this part back upwards, and then it starts on this side. Okay, so it's not like the graphical representation on the image that we saw where it does it all at the same time. Like it doesn't go this step and then this step and then this step and then this step and then this step. Like that's not how it works. It starts off actually when I drew the arrows back up here, I meant to just draw them down, combining downwards like that. So it goes to this step first. It goes all the way here before it even starts off doing this part right over here. And then it does all of this like right here before it even does all of this in the right side. So we'll see exactly why that is, and once we run it, we'll also try to debug it and see what we get from that. Okay, so this is what I have for our implementation. I have some test cases here, and if I just run some test cases right now, you can see that we ran 2 tests and we failed. None does not equal to 0, 1, 2, 3, 4, 5, 6, whatever. So these are the test cases that we have. One is a random test case, and the other one is just one I wrote myself manually. Alright, so given an array, right, we're passing in this array here of 1, 2, 3, 4, whatever number that is. You know, it's an array of numbers. How do we start off sorting this? First thing we want to do, it is a recursive algorithm, like I said before. So the first thing we want to do is we want to put a base case. So what happens is if there's a certain condition met, okay, you want to return the same array back. So if length of the nums is less than or equal to 1, we want to just return the nums back again. So return nums. So it doesn't make sense to you right now. If this doesn't make sense to you, it will probably make sense once we continue writing it. This step is just like very mandatory because we are going to recurse. So then what we want to do is we want to split in half now. So we want to split the array in half. So how do we do that? First we find the midpoint. So let's get the midpoint is equal to length of nums, and then we'll do a floor division of 2 so that we get a whole number instead of a float. We'll get a whole integer, and then that's the midpoint. So then we'll do the left side. We can just say left just to shorten it, or actually, yeah, we can say left side. I guess that makes it more sense for learning purposes, but I guess if you want to shorten it, you can say left is equal to this. So left is equal to the nums up until the midpoint. So everything from the beginning until the midpoint, okay? And then we'll do right side. Right side is equal to nums, everything after the midpoint. So the left side is going to be everything up to the midpoint, and then the right side is going to be the midpoint, and then everything after the midpoint. Okay, so that's that. And then what we want to do is we want to recurse now. So we want to recurse until it gets down to the very bottom. So we want to do left side is equal to merge sort left side. So we want to recurse, and this is why I said it's going to go through the left side first, because it's going to hit the left side statement first. So it's going to solve the entire left side first before it even touches anything on the right. It's going to go, where's that? It's going to go all the way down here, like first, right, before it even goes here, Well, it will do the split, like the entire thing will get split at the initial step, but then it goes to this step here, and then this step, and then it goes to this step, and then this step, and then I guess it goes this step, and this step, and then this step here, and then this step here, and then it starts off this entire side like that. So you guys know how it works now. I mean, I don't know if I'm going to debug it, because we'll probably debug it anyway, so whatever. So that's the left side. We're gonna recurse. And the right side will be merge sort of the right side. Okay, so after the entire left side is done, then it proceeds to the right side. I don't know why the graphical representation of it shows it doing it all at the same time, that's not how it works. That's not how it's working. Okay, so left side and right side, and then what we'll want to do is we want to make a new method of merging. So I'll actually write that down now. So define merge. So all the stuff before was just splitting. Now we're gonna merge everything back together, and this is where the sorting happens. So we'll do a left side, and then we'll take a right side, and then we will have a final array, or actually a merged array. Let's call it merged array. Initial is gonna be nothing, okay? And then here, we want to return merge left side with merge right side. Okay, so we have a merged array here. I'm missing E there, so merged array there. We're just going to return merged array after we are done with it. So what we'll do is we're going to go through the left side and right side, and we're just going to do like a finger picking, I guess, see which one is higher, which one is lower, and then whichever one is higher we'll put whichever one was lower, actually, not my bad. Whichever one is lower, we'll put in this merge array, and then whichever one's higher, we'll skip for now. It's that step. While left side, while the length of the left side and length of the right side and is greater than 0. So while there's more than one value, there's at least one value in there. Okay, if left side 0 is less than right side 0, okay, do merged array dot append left side 0, okay, else right side appends merge array dot append right side 0, okay. And then here what we'll do, we'll pop out the left element once we added it. So left side dot pop and pop out the 0, and then we'll do the same thing here, right side dot pop 0. I don't know why there's an error here. What's going on with this error here? Merge array dot append. We forgot to put it in append. Append right side. Okay, so that's what's gonna happen. And then at the very end, we will just add everything to the array. So so for whatever's left. So it's either going to run this one or the other one. So for I in left side, okay, merged array dot append I, okay, and then for j in, actually, yeah, we'll just put j in right side. Actually, it should just be I because it's going to be an initial spot anyway. We'll do merge array dot append I as well. So this is gonna be the same thing either way. So what happens here is, let me walk you guys through it. So it's gonna, so we'll pass in a left side and a right side, okay, and then it's just gonna pick out whichever one is less than the other one. So like left side is less than the right side, for example. It's gonna add that left side to this array here, right here, and then it's going to pop it out. So then it's gonna have a new 0 number, and so on and so forth. And at the very end, once one of these is like greater is 0, once, like, let's say the right side becomes 0 first, then the left side still has some value, so it will have to be emptied out, and that's why this statement comes in. This gets run, and then because there's nothing left on the right side, this just gets skipped. This gets skipped. So then it returns the merge array, and then it kind of recurses through, and then you get the final array merge at the very end as a final result. So that's the entire algorithm. It might not seem like a lot, but this is the entire thing. And let's go ahead and run it. I think this is completed. Let's see if it works. So we have an invalid syntax somewhere, line 25 for I in right side. What's going on here? Merge array.append for I in right side. Okay, for I in right side instead of just for I right side. Okay, let's run this again. Failed. What happened here? Contains 2 additional elements. What's going on? What? That doesn't make sense. 1 1 1 1. Oh, we're just adding 1 somewhere. Where is that? Why are we just adding 1s? Left side 0. Okay. Length of left side is greater than 0. Right side 0. Why is it adding 1s? That's weird. Nums is equal left side equals merge sort left side. It's merge sort right side. Listen equals to 1. Okay, that should be good. Okay, here it's like the same exact thing. Okay, that's not what we're supposed to do. It's supposed to be like that. Midpoint until the, or actually, wait, yeah. It does get confusing sometimes, I think. No, it's the opposite actually. So this should be here, this should be there, and then that should be good. Okay, so there we go. It works now. Now we ran 2 tests and we passed everything. And this is like 100 test cases, by the way. So this is 101 test cases, and it does it really, really quickly. You guys can see that it does 100 test cases in 0.005. What we can do is we can print out the results, but this printing it out will actually take longer than doing the actual sorting. So print array to sort, and then we're going to print sort array, and then we're just going to print a new line afterwards. And then we'll run this, and you guys can see down here it kind of took 0.007. Like I said, the printing took more time than the actual sorting. So the sorting took like 0.005, I guess, as you guys saw, and then the other one took like 14 times more than that. So you guys can see it sorted this array here. So this is the array that was given, and then it sorted it into this final one right here. And you guys can see it's very efficient. It does it very, very quickly. Yeah, I guess now what we can do is we can debug through it. So I'll put a break point there, and then I'm going to run this one. Let's just run this, and then we'll step through it. So the first array we're given is this array here, 13, 0, 3, 863. It should split it up to the 13th point, and then have 2 equal left and right sides. So let's see if that works. So left side and right side. Left side is 13, 0 up to 33, and then right side is everything afterwards. So 70 up to until 4. Let's see if that's correct. Do we have the original? Yeah, so up to 33, and then that gets split up. Okay, so that's correct. And then you can see it goes to the left side first, right? Now it's just doing the left side. So you guys can see it, 13, 0, 3, 63, 35. That's the left side only. And then it's going to go down to the left side again, and now the left side is at 13, 0. So you guys can see it's going to the left side first, whereas the graphical representation is completely incorrect, doing it all at the same time, which is just incorrect. That's not correct. That's not how it works. And so here, unless there's a different algorithm that does it at the same time, whereas I'm not familiar with that one. But as you guys can see, it's doing the left side first, and then it's doing the right side. And we still haven't even reached the merge part yet. So here at the very beginning, we have 13 and 0, the first two elements in the entire sort. So 13 and 0 for the left side is 13, the right side is 0. Now it's going to merge them together. So the merge array is this one, while left side is greater than 0 and while right side is greater than 0. Pick out which one is less and then add it to the merge array first. So 0 is less than 13. So I expect 0 to get added first, and I'm correct. 0 is added first, and then it adds all the remaining items that are available, and then it just adds 13 to the merge array. Now it's going to return 0 and 13 upwards. So now left side is equal to 0, 13, and now the right side is going to equal to 3, 63, 33. That still has to merge, so it's going to go all the way down again. Left side is equal to blah, and then right side is equal to blah, and yeah, so it keeps going down, then it merges everything. And I'm just going to skip through a few different steps here, and everything gets pushed back up. So at some point, the entire left and right side is going to get merged. It's already combining the entire initial, the 5 first ones for the first split. So now we have the entire left side here is completely sorted now. So where is that? So here the entire left side is sorted 0, 3, 13, 33, 63. Whereas initially, you guys saw the initial argument was 13, 0, 3, 63, 33. That just has been sorted now. Now it's 0, 3, 13, 33, 63. Now the right side gets sorted. So you guys can see now the right side is getting sorted, and you guys saw that it does the left side first, and now it does the right side. So yeah, the graphical representation again is wrong, and this is the way it's supposed to be done. So that's basically it, guys. I hope you guys enjoyed the video. If you liked it, put a like. If you disliked it, put a dislike. If you guys have any questions or comments or criticism or anything like that, post it down in the comments below. If you want to see more videos like this, subscribe to the channel. Thank you guys for watching.